Alright, so this is the fifth section here in our quadratics unit. I actually don't have a completed set of notes that I'm working on for this one, so this will be interesting. Hopefully I can do it without making mistakes. We'll see. So basically this section is all about these equations here. So this is our quadratic equation. We've got y equals ax squared plus bx plus c equals 0. So this is kind of like your y equals mx plus b. It's just your standard version for the equation. Now this is what we're going to be using today. So in order to solve this equation, we've looked at factoring, we've looked at completing the squares, but now we're actually going to look at this equation here. So this will work every single time no matter what. All you need to do is plug in the b, a, c values into this equation and it solves it for you. So this first little part here, I'm not going to go over this part specifically. Basically, it just proves the equation works. I'm not going to do that. I don't need to go through it. I'm just going to start here, finding the roots. So what you're going to do is, you'll go through this equation and we'll write this out. So we've got x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. This will be given to you on the formula sheet. You do not have to memorize it, so don't worry about that. So in this, 8 here, that's the a term, 14 is the b term, negative 15 is the c term. So I just plug those numbers in. We get negative b, which is 14, plus or minus the square root of 14 squared, minus 4 times a, which is 8, times c, which is negative 15. We get this divided by 2 times a. So here's our expression. This is what we'll get. So when you do this, yes, you could plug this straight into the calculator first. I do not want you to do that because I don't want you to get the full thing, and it's going to simplify your equation a lot. The step I need to see is this. So you need to first put in what is inside this square root. So we got 676 is what's inside the square root divided by 16. So for sure you need to show me this step. So from there we look and see, can I take the square root of that? And conveniently for this one we can. So it's negative 14 plus or minus 26 over 16. So then we can actually deal with this. From here you can just plug it into the calculator. So you'd go negative 14 plus 26 divided by 16. So we would get 0.75, or 3 over 4 is one solution. And do it again with the minus. So negative 14 minus 26, then divide by 16. We'd get negative 2.5, or negative 5 over 2. So these are my two roots. So this is how you'd go over and do that. You could do this for the other examples, give those a try. Now something that's really important with this quadratic equation is what's called the discriminant. So it's often referred to as this triangle, which is a Greek letter delta. And this is equal to what's inside of the square root. So what's inside the square root will actually determine what happens to our equation and determines how many roots we have. So let's look at this. So I'm going to do these three quite quickly. So go through, plug this in, x equals, so negative b, so negative 4 plus or minus the square root of 4 squared, minus 4 times a, which is 3, times c, negative 2, all divided by 2 times a, which is 3. So we get this. We can plug that into the calculator, which I'm doing right now. So we would get negative 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 2. So we'd get the square root of 40 in here over 6. So notice in this case, we've got a positive number inside the square root. So this value is positive. So the discriminant here is greater than 0. Therefore, because of that, we're going to have 2 roots. I'm not going to go through and solve this. This is going to, you'll get some number with this. But because this is positive, when I do the plus or minus, I'll get 2 distinct values. That's in contrast to if I look at the next one here. So x equals negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 3, times c, which is negative 1, all divided by 2 times a, which is 3. So plug that in, we get 4 plus or minus, so 4 squared minus 4 times 3 times negative 1. So that would give us the square root of 28 over 6. I think something's wrong with this one. Anyways, again, the discriminant's greater than 0, so we're going to have 2 roots. There should have been a case where it was 0. Did I mess something up with this? B squared minus 4 times a times c. Nope, that's right. So let's do this next one here. X equals negative 10, so it will be positive 10, plus or minus the square root of negative 10 squared, minus 4 times a, which is 5, times negative 20, 2 times a, which is 5, so 10 plus or minus, and then the discriminant, so 10 squared minus 4 times 5 times negative 20. Yeah, none of these are doing what I want them to do. So this one again, if this is greater than 0, we've got 2 roots. So depending on what we've got here, this should give us something that actually makes sense. So what I've got with this is, imagine, because something's wrong with the numbers for these, because this should have worked 3 different ways. So with this, imagine what would happen if inside my square root, so imagine if here, what would happen if b squared plus 4ac, what would happen if this equals 0? So if this were to equal 0, when I look at the equation, so x equals negative b plus or minus the square root of this discriminant divided by 2 times a. If the discriminant is 0, we would just have negative b plus or minus 0 over 2a. So this would give us only 1 root. So that's why if the discriminant equals 0, you'd get just 1 root. If suppose that this is, so the discriminant here, suppose this is negative. So if I plug it in, we'd have x equals negative b plus or minus the square root of some negative number in the root. This can't work. You can't take the square root of a negative number, so you'd end up with 0 roots. So this is what would happen in these cases. So if the discriminant is greater than 0, we'd have 2 roots. If the discriminant is equal to 0, we'd have 1 root. And if the discriminant is less than 0, we would have no roots. There are what we call imaginary, but we don't need to worry about that. So that is this. That's the purpose with that. So if I ever ask you a question where I say, how many roots are there? And I don't ask you anything else, you can just simply look at this part that's under the square root. You can look at the discriminant and see what is that. If it's positive, 2 roots. If it equals 0, there's 1 root. And if it's smaller than 0, it's 0 roots. So that is the quadratic equation. Again, these equations I'm going to give you on your formula sheet, so you don't need to memorize this. It's all going to be there for you, but you need to know how to use this.